The biggest graphics revolution in gaming history. And most people turn it off. You've seen the trailers, you've heard Nvidia's promises, and maybe you've tried it yourself and wondered why your GPU is dying for results that look almost identical. But the real story of ray tracing isn't about technology, it's about marketing, bad optimization, and a gap between what was promised and what was delivered. And by the end of this video, you'll know exactly where ray tracing actually stands and where it's going. To understand ray tracing, you first need to know how games normally render graphics. Every frame, your GPU converts a 3D world into a 2D image using basic math, transforming geometry, then figuring out what color each pixel should be. For lighting, it uses clever tricks, approximations that look convincing but aren't physically accurate. It's fast, it's efficient, and it's been the foundation of real-time graphics for decades. Ray tracing throws that approach out. Each ray can bounce multiple times, sampling light contribution at every surface it hits, which is why a single frame can require billions of ray calculations. The result is accurate reflections, realistic shadows, and lighting that behaves like it does in the real world. The problem? Simulating light is expensive, very expensive. When Nvidia launched ray tracing in 2018 with the RTX 2080 at $700, the promise was simple. This is the future of gaming graphics. But the reality? In Battlefield 5, one of the first games to support it, ray tracing dropped frame rates to 40 to 50 frames per second at 1080p on a $700 card. And it's been a similar story ever since. Ray tracing looks incredible in Nvidia's marketing, but enabling it in an actual game means either buying the most expensive GPU on the market or relying on DLSS, Nvidia's AI upscaling technology. Instead of rendering your game at full resolution, DLSS renders it lower and uses AI to reconstruct the missing detail. The results are impressive and in many cases genuinely hard to distinguish from native rendering. But the point stands. You're not actually running ray tracing at full quality. You're running a compromised version of it, upscaled by AI just to hit acceptable frame rates. And conveniently, every new GPU generation brings a better version of DLSS that makes ray tracing slightly more viable. Which means if you want ray tracing that actually runs well, you're on Nvidia's upgrade treadmill, whether you like it or not. But here's the thing. Ray tracing isn't universally bad. In the right game, it's genuinely stunning. Take Cyberpunk 2077, a slow-paced, visually driven experience where wet streets reflect neon signs, windows mirror the city, and every light source behaves like it does in real life. In a game like that, trading 50% of your frame rate for that level of visual fidelity is a reasonable decision. Nobody is playing Cyberpunk to win. They're playing it to feel something. But switch to a competitive shooter and the entire calculation flips. You're moving fast, tracking enemies, reacting in milliseconds. You're not looking at reflections. You're looking for your opponent. Every lost frame is a disadvantage. Ray tracing in that context isn't a visual upgrade, it's a handicap. In theory, ray tracing sounds like a perfect solution. You get an option to turn it on or off. Enthusiasts get photorealistic lighting, everyone else gets their frames, everybody wins. In practice, however, implementing ray tracing is expensive and time-consuming. Every hour spent integrating and debugging ray tracing is an hour not spent optimizing the game for the people who will never enable it. And that cost shows. Games ship with inconsistent frame rates, stuttering, and performance issues that have nothing to do with ray tracing, because optimization simply wasn't the priority. Ray tracing became a bullet point on the back of the box, a feature marketing could point to and say, this game is next generation. Most players assumed it made the game look better, enabled it once, watched their frame rate collapse, and turned it off permanently. The development resources were spent, the performance cost was paid, and the feature went unused. But ray tracing isn't even the final destination. Path tracing takes the concept further. Instead of simulating specific lighting effects separately, it simulates the complete journey of every ray of light in the scene simultaneously. The result is genuinely photorealistic. So why don't games ship with path tracing instead? Because even the RTX 5090, Nvidia's most powerful consumer GPU, struggles to run it at playable frame rates without DLSS. And if the best card money can buy can't handle it, the average gamer running a mid-range GPU from 2 years ago has absolutely no chance. Path tracing is what ray tracing always wanted to be. We're just not there yet. Ray tracing is real technology with real results, but it was sold to us before the hardware could actually support it. Nvidia built a marketing machine around a feature that cost hundreds of dollars to run and delivered underwhelming results in most games. It's getting better, slowly. Path tracing shows where this is all heading, and in 10 years, this conversation will look different. But right now, for most people, ray tracing is a checkbox that costs you frames and gives you back less than you'd expect. If you play slow-paced, single-player games with a high-end GPU, turn it on, it's worth it. Everyone else? Your frames are more valuable. It's getting there, just not yet. Jesus loves you, God bless you, and I'll see you in the next one.